thing, if you want to add this, I don't know why it does that little noise every time I start recording. That's weird. If you want to add any of this to the bottom part, you can. This, like I said, this will be posted on It's Learning if you want to go back and add that. But what I want to look at in Delta Math, your assignment, like I mentioned, is a little different. The first 3 problems are the same for everybody, okay? Then the next 3 are randomized, okay? So I'm going to go through this first one with you. So we want to do x squared minus z to the 4th power. We want to expand this, okay? So what I suggest doing to show your work, or until you really get a better hang of this, oops, go back to my whiteboard here. Yes, this Delta Math just opened today and it'll be due on Thursday. All right, so I'm going to write out my binomial. So I've got x squared minus z to the 4th power, and I want to expand this. So the first thing I'm going to do is I'm going to write out Pascal's triangle here to see what my coefficients should be. Loving it. Great. Oh my gosh. All right, so that's degree 0, 1, 2, 3. So I need one more. So this is degree 4. Okay, so these are going to be the coefficients. Okay, and you don't have to write out the triangle every time. I'm just putting it here so you can see why I'm using these numbers. You can refer to your notes when you're looking for it. All right, now I'm going to identify x squared as my A and negative z as my B. Okay, so I'm first going to expand it using just A and B because I think that's easier for us to think of it as A plus B to the 4th. And then we'll go back and substitute those in. So I know my leading coefficient would be a 1, and then I would start with A to the 4th, right? And then I would have my, oops, I just didn't get my coefficient there. 4 would be the coefficient. I'd have A cubed B. And then I'd have 6 A squared B squared. And then 4 AB cubed. And then I'd be back to the 1, and it would be B to the 4th. Is everybody cool with that expansion? With just the A's and the B's? So now I'm going to make those substitutions. I'm going to plug in everywhere I see B, I'm going to put negative Z. And everywhere that I have A, I'm going to put x squared. So this is going to be x squared to the 4th plus 4 times x squared cubed times negative z plus 6 times x squared squared times negative z squared plus 4 times x squared. Oh, I guess I didn't really need parentheses for that one. Times negative z cubed plus negative z to the 4th. Still good? Do y'all remember your exponent rules? If you have a power to a power, what do you do with those? You multiply them, okay? You multiply a power to a power, okay? That's an exponent rule. Okay, so we need to simplify. This would be x to the 8th. This is actually going to come out negative because the negative z is an odd power. So this whole term will end up negative. So I'm going to write that as minus. No other number for the coefficient. It'll stay 4. And then I'll be x to the 6th z. This one's going to come out positive because the negative is squared. It'll be plus 6x to the 4th z squared. This one will come back out negative. 4x squared z cubed. And then this one will come out positive again because it's the negative to an even power. So plus z to the 4th. So that is my simplified form of that expansion. Y'all follow? Does that make sense? Okay, good. So I'm going to go. You can, if you want to go ahead, at least write that down somewhere. If you're not logged into your Delta Math, that's the answer for everybody's number 1. You don't want to have to do it all over again. Okay, so that's what we would put here. Would say x to the 8th. Somebody read it out to me. Did anybody write it down? X to the 8th. 4x to the 6th z. Oops, my z is not in the power though. Okay, and then it's back to positive 6 and minus, what was it? X to the, was it just x squared? And then was it z cubed? Did I miss something? 6x to the 4th z squared minus 4x squared z cubed. Yeah, okay. And then it was back to plus, right? And it was just the z to the 4th. Okay, and then you can walk through, you can see this explanation. They pretty much did the same thing we did. They did the Pascal's triangle to that row. That's the row of the coefficients. They called ax squared and b negative z. The degree was 4. Okay, so that's exactly the process we did. We didn't write out quite as much, but essentially we did the same thing. Okay, all right, so let's go try another one. All right, let's see if we might be able to do this one without writing anything out. Or maybe we could just go refer back to our triangle at least instead of rewriting it out. So this is the 5th degree. So in my triangle, where is my triangle here? So n is 5, that's the 1, 5, 10, 10, 5, 1. So those are going to be the coefficients, right? And since both of these are just variables, there's nothing fancy in here. Those coefficients aren't going to change. They're going to stay. So what's my first term going to be? A to the 5th, and then no b, right? It's b to the 0. I don't have to write that. Okay, and then the next coefficient is 5. Oh, thank you. I didn't even read that. They only want the 5th term. I'll go ahead and write it out so y'all can see it. And then we can, well, we don't have to do it all. So let's go back to our triangle. Good catch. So the 5th term, 1, 2, 3, 4, 5, is going to be the second to last. So that means our first term, our a, is going to be down to a power of 1. And what's the b power going to be? To the 4. It's going to be n minus 1. Okay, so we'll have a coefficient of 5. Okay, our a will be to the power of 1, and our b will be up to the power of 4. Does everybody agree with that? Okay, You can go through, see the explanation. That's essentially what we said. All right. Let's see if we can get one more in before the bell. All right, the third term. Okay, this one's a little trickier because there's coefficients and variables in the binomial. Okay, but let's think about it. The fourth degree, so in Pascal's triangle, I'm looking at the 1, 4, 6, 4, 1. So they said the what? The third term. So that would be the coefficient of 6. And then by then, the 3x would be to what power? 3x would be down to squared. What's 3x squared? 9x squared. 9 and then just the x squared, right? Okay, what would the 5y be to what power by that term? Okay, so again, show this to you here. We're looking at the very middle one. So both would be squared. That's correct. What is the 5 squared? 25. So we've got the 6, the 9, and the 25. So we have to do 6 times 9 times 25, which is 1350 is what our coefficient will come out to. And y'all said they would both be squared, right? Oops. There it is. We got it. So again, they're showing combinations. Y'all do not know it in that terms. You don't need to think about it in terms of combination. I would look down here and just say, this is what we did. We said 6 and then the 9x squared and then the 25y squared. And that's where we got the 1350. Everybody good with that? Okay, so y'all have only got 3 types of questions left to do, 3 from each, so that's 9 questions left. Remember, tomorrow is a flex day. You can finish this, and then you can work on finishing your circuit on rationals or your Alex, check your understanding on polynomials. Okay, so just kind of a mixed practice on whatever you need to finish up tomorrow.